Hi guys, I hope you are fine. So now we are gonna solve the LeetCode 75 problem, and the first problem from DP multidimensional. We have solved the first problems from all previous topics. Now this is the time to solve first problem from DP multidimensional. So I have solved this problem for you. So now I am gonna explain it in a very depth manner. So the problem is unique paths. So it is a problem of medium difficulty, and topics are, of course, DP, maths, and combinatorics. So this terms I have heard first time. Anyways, so the problem is there is a robot on an m cross n grid. Robot is initially located in at the top left corner, that is grid 0, 0. The robot tried to move to the bottom right corner, that is grid m, 1, n, 1, and the robot can only move either down or right at a point in a time. Okay, so this is the question in which we have given a robot and it can only move to the right or down. Okay, it is it is initially at the position of 0, 0, and we have to return the maximum number of ways in which robot can reach this point. We have to return all the paths, right? We don't have to return the exact path, but we have to return the total number of paths in which robot can reach this point. So this is the question. We so there is two three approaches to solve this problem. I am starting with the DP 2D DP, two dimensional DP. Then I will optimize that approach. Okay, so this is 2D DP, in which what I'm gonna do is, so let's suppose robot starts from here. So there is only one way to reach here, which is it is starting here, right? Now we will count at any point, let's say at this point, that how many ways robot can reach here, or at any so so that is at any point I comma j. How many ways to reach this point, right? So there are ways which is counted as total number of ways in which robot can reach this point plus total number of ways robot can reach this point. So there are only two sets of ways in which robot can reach this point, which is ways in which robot can reach I comma j minus 1. So in total number of ways robot can reach this point plus total number of ways robot can reach this point plus ways I minus 1 comma j. There is a recursive approach to solve this problem, but I'm not going to explain that recursive approach. But to start the DP approach, we have to think about that recursive approach and applying dynamic programming. So the basic concept of dynamic programming is to remove the unnecessary calculations, right? Repeated calculations, I can say. So we can remove the repeated calculations by storing the result of the repeated calculation in an array, which we call dynamic programming DP array. Okay, so at any point, so we will create a function way. Let's say we will create a, so I'm going to explain you the recursive approach. We will create a function ways in which I can pass I j, which will return me the total number of ways to reach the point I comma j. Okay, at the base it has 1, right? So way 0 comma 0 is 1. So ways I comma j is nothing but ways. So I have write it down here, copy this. Okay, so this is the top down approach in which we will assume it from here and we will reach here. Okay, so this is the recursive approach. Now I'm going to reduce the repeated calculations using dp. So what I can say, that total number of ways of reaching this point is nothing but total number of ways reaching this point plus total number of ways reaching this point. Okay, so at any point I comma j we can so I have already written it here. So I can say ways is equals to dp I j is nothing but dp I j minus 1 plus dp I minus 1 j. Okay, so I have created a 2D array dp which has I number of which is n number of n so this is, we are creating a dp. Okay, and dp 0 comma 0 is 1 because there is only one way to reach this point. Okay, now I am iterating through dp, and if I minus 1 greater than 0 means so if I minus 1 greater than 0 means I is 1, so dp of I is so we are so if we are at this label, so we can calculate the points from this label also, because if I am at this label, right, I cannot calculate the points from this because it is out of range. So that's why I am using this condition variable, and same with this j, because if I am at this label I cannot calculate from j minus 1, because so I will start from the j is equals to 1. Okay, and I am returning the ways to reach here, which is m minus 1 n minus 1. So this is the db2d approach, and I have solved this problem using this approach in 37% beat, 32% beat. Okay, now now you can see that, okay, let's say I'm here, or let's say how many number of ways to reach this point, right? Or how many so okay, let's say I am here. Okay, so I can reach all these points in only one way, because I can reach all these points in only one way, right? So I will initiate a dp array with all the elements as 1. Now as I am at this point, I can see I can reach this point in from here, and from here I can reach this point from here and here. So what I am going to do, optimize dp, right? So what is optimized dp? So I am going to create a 1d dp, right, which is, let's say, initial label, which is of length, which has length n 1 comma 1 comma 1 comma 1 comma 1, let's say, because I can surely say that I can reach all these points in only one way, because there is no other way from upper side, there is only one way from this side. And now I am at this point, I can reach here from one way only, right? I can, from how many ways I can reach here? So there are ways from this side and this side. So this side is already calculated here, which is 1. Just I am not going to use any other layer but on this element only. So I am going to overwrite it on it only. So what it become? This become 1 plus this previous one. So 1 plus 1 is equals to 2. So now my dp is nothing but dp I dp j minus 1. Okay, so this is nothing but dp of j plus dp of j minus 1, right? dp of j is equals to, so what is implies it, right? dp of j, this is the new dp, this is the dp of new label. This j is from older label, because no other point is going to modify this j, right? And this j is from this label, because this is getting modified with the new label, right? So all these points is getting modified. So let's say I am at this point, see, right? All these points are getting modified with the new label. These points are okay, not here, but okay, let's say this is x, this is x1, this is x2, this is x3, this is x4, okay, this is x0. So let's say I am working here, so I can say all these points are getting modified with the new label because of this formula, right? I'm at this label. This x2 is currently of I minus 1th label, right? This is not getting modified with the ith label. So now this contains the data from I minus 1 label, so I don't need any two-dimensional DP for calculating data from I minus 1 label, because I have the data of I minus 1 label in my current 1D DP only. So I can use that. I don't need to store it anywhere else, right? So what I can say, this has this x1, so the x1 here is nothing but dp of I or j minus 1, right? And this x2 is nothing but dp of I minus 1, because it has still the data of I minus 1, and sorry, this x2, currently x2 is nothing but dp of and j, right? Because it is the jth point in the this dimension, in the horizontal dimension, and in the vertical dimension it has the data from I minus 1. So now what I can say, so the x2, which is nothing but dp of I j, which will gonna become dp of I j, is gonna be become by using x1 plus x2. So this is the only formula, right? I j minus 1 plus I minus 1 j. This is the only formula. See, I j minus 1, I minus 1 j. So that is just that thing I'm gonna use in this thing, right? I'm not going to what I'm saying, I'm not going to make a 2D DP for this, because I can use 1D DP here. So that's all I'm doing here. I'm making a DP initially at 1, I in the range m minus 1, and j starting at, let's say, 0, right? If j is smaller than n, dp, okay, so yeah, dp of j, right, is nothing but is gonna add with the with the dp of j minus 1, and j will become 1, okay, and j is equals to 1, because we are going to start here, we cannot add the dp from this side only, right? So yes, this we will get dp from n minus 1, and I hope we'll, so let's so run this approach, and I'm sure this will get submitted. So yeah, this is also getting submitted. So as you can see, we have reduced our, so time complexity is still n cross m, but we have reduced our space complexity from n cross m to n, right? So in it at here, time complexity is nothing but n cross m, and space complexity is also n cross m, right? But in this approach, time complexity is still n cross m, but space complexity we have reduced it to only n. We have another solution in which we can solve this problem in time complexity O1, space complexity O1, right? So I'm not going to explain you this solution. This is this is just a mathematical formula for solving this problem, because there is no other constraints. There are only two variables, m cross m and n, and we have to find something from these two variables. So there is a mathematical formula formula. So I'm leaving it up to you. You should find go and find that formula and try to solve this problem using that formula only. I suggest you not to go in this solution section. So it will be a very easy task for you to find the formula from this solution section, but that is not very recommended. Go and find the formula in the in some Google it or anywhere else, so that you will get learn about multiple things. So yeah guys, I hope you got some knowledge from this video, and got to know about how to optimize ways in the DP, how to convert multi-dimensional DP into the single dimensional DP. So yeah, I'm stopping here. Thank you for your time. If you have any doubt, you can ask me in the comment section. Thank you.